Today we want to continue from some of our lessons. We'll try and have as many extra lessons as is possible, although this only makes sense if you guys keep up with what we'll be doing. So we still just want to build on the concept that we've actually been working on, which is how to develop and design a project and also use different aspects of our programming. So we can call this one working with characters. Where we'll get into a program similar to what we did before, but we want to add a bit more context to it so that we can see the different perspectives of how this works. So we want to include a header file. That's the first thing we want to do. And the header file we want to use is called conio.h, which is this one. And we would pretty much want to work with a simple program that uses a new function that we can actually use to get characters. So let's get started. So the first variable we want is dir, and dir we want this to be equal to, in quotes, a. From there, we want to have two declarations, where first one is x, we say is equal to 10. We put a comma, we put y is also equal to 10. From there, we want to be able to put a C out, and then our C out should read the following. You should type enter quit. Outside of that, we then now want to have our control statement where we put while, we open brackets, and then we check for dir, which is our variable, and we say is not equal to, we put our quotes, and we put a /r. Okay, so what we are trying to get with r is, at this particular instance, we want to check if enter has been pressed. That's what we want to be checking for. Then from there, we then now want to have our code. So we can actually make our life simpler by learning some of these small little concepts, and we can use, or we can apply them to the various options that we can work with whilst we are doing our programming. So in this case now, we want a C out, and our C out should then get us the options that we want to get. So the first thing we want to get is enter location. Sorry. we want to be able to use location. So the location that we want to work with, we want to be able to work with X and Y. So let's change this and say location is, and then we put our X, we also put our Y. We can put an end line, maybe between our X and our Y, let's put a quotation, or let's actually put something in between. We can put that, so that we've got a demarcation between the X and the Y. Then outside of this, we then want to get a direction. So we would want C out, enter direction, and then for our valid directions, we want the following. We want north, south, east, west. Those are the directions that we want. We can also put a new line, put our quotation, we put our semicolon. Then from there, we then want to check the direction that we get. So we put our dir is equal to get che, and get che will then get our input. So this pretty much works like our cin. We then want an if statement to check our dir, and the value we want to check for is our n. And then if this is true, then we want to decrease the value of 1. Else, if our dir is not equal to n and is equal to s, we would want to increase the value of y. So at this particular instance, we're saying at this point, this marks our north, and at that point, this marks our south. So we can also then put the following for the remainder, whereby it's an else if and an else if, and it follows suit that we'll just be working with the same construct, whereby it's dir equals the next value is east, so we want e, and then the last value would be dir, and the value becomes west. So we can also put east, and there we put west. So for east, we say x plus plus, and for west, we say x minus minus, and then we are done. Okay, so let's just run this and see our output. Then we'll explain from our output. So when we run our program, here's what we'll get. We'll get press enter to quit. Our location is 1010. So we then need to enter a direction. Let's say we put S. Okay, I think something went wrong. Let's try it again. Yes, this time it worked. I don't know why it gave us that problem. So we are saying the moment we put S, it then gave us our location 10 and 11. Let's put N. Our location is 10 and 10. Let's put W. Our location is 9 and 10. Put W again. Our location decreases. W again increases. We put E. Our location changes. So basically, this is what our code will be doing, whereby each element that we enter will then give us a direction that we are working with. So if we press a location, it will give us a change in the x and y value. And the moment we just press enter without having a location, it will give us a result based on what we have. So this was one of the examples we can actually work with in terms of our control statements. Let's go to the next control that we want to work with. It's still a control statement, works well with the existing control statements that we've worked with, but this one is a go-to statement whereby we want to see how we can manipulate our existing concept or create a new concept based on what we want to achieve. And here's how we can have our values working. So we can create an integer value. Let's just say our value is equal to nm, where nm is equal to 0. So we actually want to start from 0. This becomes our counter value, whereby we want to add to this value. At the same time, we want to create a control. So our control would then be something that adds to the initial value of nm. So we can call it inc or inc. so that we know that it increments, and we want to increment the value of nm. And to increment the value of nm, we want to be able to specify how we would want our value for nm to be. So we can say plus equal to, and then we want to be able to say 50, which becomes what we want to increment our value by. So at this particular instance, we can say increment value of nm. At the same time, we then want to see what the value of nm is. So we put a C out, and then we state that val equals, we open and close brackets, we put our nm, we open and close brackets, we put a new line. Let's actually put a new line before val as well. And then we close our line. From there, we want an if statement. And in our if statement, we want our nm to be less than 200. And then we want to use our go-to statement, whereby our go-to statement will then take us to inc, and then we close our program. So this having been complete will then give us a full run of what our program would give us. And here is what our program gives us. So we've got val being our cout, and then our cout starts from 50 because we've initialized our val to be 50. So each time that we increment, we're actually adding 15, 15, 15 until we get to the last value, which is 210. But we have actually done all our increments until we get to our nm being less than 200. Although now we then get to 200 because with the last increment, which is 195, we're actually supposed to catch this value and then break our system so that it doesn't give us this. But for the sake of having this running, we have done our code well and can see what this gives us. So after running our program, this is our program, we can actually check how this is going. When we start, our value is already incremented already. So nm becomes 15. The next run, it becomes 30. The next run becomes 45. The next run, it becomes 60. The next run becomes 75. The next run, it becomes 90. The next run, it becomes 105 until we get to 210. So we don't want to see 210. We might have to modify our if statement. And to modify our if statement, we'll do following. Let's just put enter so that we close that. To modify our if statement, we'll simply put an and then we say nm is not equal to 195, which then gives us a room to say the moment we get to 195, we want to stop the program. So if we run our program, we should have gotten rid of that problem of our 195. So it then means at least we have kept within our 200. Each increment will give us all the values that we want, but um, we've got our values between 15 to 195, or all being below 200. So let us move on. There's a loop that we actually didn't get to look into, and this loop is a do while loop, which takes on from our while, in that it will just add an extra concept to our while, whereby we first take the action, then we put our condition, or we work with our condition, so that we can see what this loop does for us. So we can be able to implement our do while loop in the following manner. We simply want to keep the program short, simple, and specific. So we would want to create our variables or our values, whereby we can say int, uh, we want our input. We also want our total, and our total is supposed to be equal to 0, so that we work with our code. So these become the variables. From there, we then want to execute our loop. And our loop starts with a do, and then we have a while straight after our do, where our while will then contain a condition. And then the condition we want is, we want this loop to only stop when our input um, is positive. So we say while our input is not equal to 0, we should continue. But the moment someone enters a 0, then we should stop. With our code, we then put the following: cout input your choice. From there, we want cin to then get our input. So the moment this is the case, we've actually got our input, and would want our input to be equal to the following. So it will be our total plus equal to input, like that. And then at the end of it all, we then want to see what our final value is. So we put a cout, and our final value comes there, where we'll then put our total, and would also then need a maybe exclamation mark and an end line. So this becomes final results, and then we get our total, and then we put our semicolon, think everything is about right. Let's run the program. So let's enter our values. So 7, 9, 11, 6, 3, and 0. Perfect. So in this particular instance, we've got our input, where each input is then added to the last input, and the total is then the total of all our given inputs within our project. So that is how we can work with the do while loop. Okay, moving on. We want to also see how we can work with nesting. And nesting pretty much means we want to create a loop, but with this loop, we want to create a loop within a loop, or we want to be able to have two conditions that are intertwined so that we get to see, or we get a result that we need to achieve through nesting. So to do that, let's get into what we call a nested for loop, where we can see an example of how this works. So let's get started. We want to put a simple program together where, like I said, we'll be working with our for, but we need to have our variables. So the first variable will be rows, the second variable will be calls, which is columns. Then we'll also need another variable that we will call character, and this will then get our characters. So let's call our character ch, and then would want to go directly to our inputs, where the first input would be as follows. The second item would be getting that input, which is our rows, and then we need a C out, which will get to give us our title. Let's actually just put in the titles. Enter number of rows. The next thing is enter number of columns. Then we put a C in, and then we put our calls like that, so that we get our column. And then we want to get the character. So we also do the same by putting a C out, and our C out gets the following. Enter the desired character. And then we put a C in as well. And with our C in, we want to get our character. So once this is done, we then want to put our loop. And our loop would be as follows. we've got the outer loop and the inner loop. So we put a for statement, we open and close brackets, we put our curly brackets, we also put another for statement, we open and we close brackets, and then this way we have actually done our loops. So maybe before we proceed, let's also add two variables. Put our I and our j, where the outer loop should then have I equal 0, I is less than rows, and then our I iterates, and then the next one will also be our j equal to 0, our j is less than our calls, and then our j iterates. From there, we then want to put our output. So our cout then gets to display our characters, and then we also have a cout that gives us nothing but a new line like that. So the moment this is done, we can be able to run our program, and if we run our program, we get the following output. So we want to get the number of rows. Let's say we put 9, number of columns, we put 12, click on enter, we get the character we want, let's put J, and this will then be our output. So basically what we are saying is we are counting the number of columns this way, we're also counting the number of rows going down, and then whichever character we put, we can be able to see output of this particular loop. So let's put a different set of values. Let's say we put 5 rows, put 3 columns, put our character as X, and this is the output of what this loop gives us. So basically, in essence, we are saying we can be able to use our loops to create a sequence or sequences that we can be able to work with and use according to the various needs that we have within our code. So let's have one more program, and then we'll end this lesson. We select the project. We then want to include function. That's the name of this project. And we then want to add something that we can work with our function. So first things first, we put a cout, and then we want to have a title, whereby we want an inline function, which then means we don't need to declare our function before we start. Also need a variable, which can be x, and then we want to have our x having been initialized to say our x is equal to 7, and then we want to then have our function. So our function will then call it get var, and then get var should then be able to pass our function x, or our value for x, into itself. So at that particular point, we want to pass value to function. From there, we then want to declare our get var, whereby our get var should have an int I, which becomes our value that we want to pass. And then we want to be able to specify what our value should be. So we want to be able to say whatever our value is, we get it and then we display it. So let's say we put a loop for I equals to 0. I is less than 5, and then we say I iterate. We then want to put a C out, and then we want to get value is, and we get our I. Although this might not give us a result that we hope for, but let's just run it and see what the output gives us. Okay, we're getting the problem that we had in the previous context. Let's actually correct that and see what it does. So that is our result. Although I'm not too happy with this result because it's not anything of value, because we've just done something that might not be very helpful. Okay, so let's just correct that and see what this gives us. Okay, so here's what our value gives us, but we don't want this. We want to actually be able to get something that we can work with. Okay, so let's say this is our result. Let's modify this. Let's actually modify it and get something that we can work with. Okay, so we would want to say this is our loop, but let it sort of give us something that we can work with. To say, instead of having this, let's actually say it gives us multiples of 7 between 0 and 5. Okay, so if we then want to do that, let's just say we put it this way. We say the first thing that we'd want is the new line, like we've got, but would want to say from that new line, let's say we get our value for I. Outside the value of I, we also then say let's get a sign, which is a multiply, and outside of that sign we then put we multiply this by the initial number that we've got in our main function, which is 7. And then outside of that, we then want to get a multiple of 7. So we put is equal to, and then we then get to multiply by 7. So it will then be I multiplied by 7, so that we get a multiple of 7. And then we put an end line like that. I think this then give us a better result. So maybe let me explain what I've just done here. I've created a cout and I've changed the output that we have, because we're saying this won't be out. Let's say we've actually called this function so that we can get the multiple of 7, and in this particular line, that's what we have done. So if we run this project, we'll be able to then get the following output, whereby we're saying 0 multiplied by 7 is equal to 0, 1 multiplied by 7 is equal to 7, 2 multiplied by 7 is equal to 14, 3 multiplied by 7 is equal to 21, 4 multiplied by 7 is equal to 28. I think that then makes better sense than what we have done. Let's maybe modify the multiplication sign and put a multiply, basically. And then we also modify this particular instance, and we say 12 is less than or equal to, and we run the program. And there we go. We now have our multiples of 7, starting from 0 all the way until to 12. So each element will then be given, and we get multiples of 7. I think we can end our lesson here, and hopefully it has been beneficial what we have done. Till next